Today, we are looking at lesson 3.4, which expands a little bit more on logs, and we're looking at more properties of logs. These are more the properties of logs we would use when solving equations, which in all honesty is lesson 3.5. We did a little bit of it last year in Algebra 2. We're not going to really get to it this year probably, unless I, pull it in at another time. Now, we have 4 rules here we're talking about. I think we probably had all these rules last year. First one is the product rule. And the idea of the product rule is that if you have a log with multiplication in it, it can be rewritten as 2 logs being added. So a log with multiplication inside of it can be broken up into 2 logs added. Similarly, quotient rule. A log with a quotient inside of it, so division inside of it, can be rewritten as 2 logs being subtracted. Okay, we'll practice that here in a moment. We also have the power rule. The power rule says that if you have a value in the power of the log, it can be moved and written out front as a coefficient. So, for instance, right here, the C. It can be written in the exponent form, or it can be moved out front and written as a coefficient. So that's our power rule. And then we also have something called the change of base rule. And the idea of the change of base rule, traditionally calculators have a log base 10 button and a natural log button, which is base E. All these other logs don't have a button on their calculator. So the idea is, okay, this is a way you can find any log on any calculator. And so log base B of R could be rewritten in one of 2 ways. We could break it into natural log of R divided by natural log of B, or log of R divided by log of B. Well, by picking natural log, guess what you have on your calculator? You have a natural log button on your calculator. So you can do natural log of R divided by natural log of B. Notice here it just says log, so that is log base 10 they're suggesting. Technically, change of base formula, you could change it to any base. Now, why you would randomly want to change to something like log base 7 or something that you don't have a calculator button for, I'm not sure. But technically, you could change to any base, okay? So, and we will demonstrate how to use that here in a little bit also. And that can be used with equations. We're going to talk about with the graph down below. So a couple different ways of where it is helpful. Okay, example 1. We're going to look at expanding and condensing logs. So taking one log and pulling it out into multiple pieces. We're taking multiple pieces and condensing them down into one log. So example A, or example 1, we're going to expand. Okay, so as we expand this, think about our properties up above that we just reviewed. How can I expand, or what's step 1 in expanding log of 8xy to the 4th? What do you think?
Log of 8 plus log of x plus log of y to the 4th.
Okay. We see multiplication, yes? Multiplication can be broken up into addition. So that is going to be my first step. And I'm going to break it into 3 logs. So log of 8 plus log of x plus log of y to the 4th. Now, in terms of simplifying, they want a little bit more from you. Okay, so we've already pulled it apart, but in terms of expanding, there's one other thing we can do. What other property can I use here?
The power rule.
Yeah, the power rule. What's the power rule say we can do?
Clog.
Or log y.
Okay. We can take the power, any powers, and write them out front. Now, what if I say there's 2 terms we want to use the power rule on?
Oh, you can put 2 to the 4th, no, to the 3rd.
Okay. So this is one, last year in this chapter, or maybe it was the chapter before, I don't know, somewhere along this time I handed out a paper that had our powers on it, because 8 is one you need to realize. 8 is 2 to the 3rd. So if we rewrite log of 8 as log of 2 to the third, can we use the power rule on that now?
Yes. It'd be
Yeah.
3 log 2.
So, yep, the idea is the power rule can pull out front there. So we have 3 log 2 plus log of x is just carrying down plus,
Or
pull the 4 out front, 4 log y. Might I say, you guys have some interesting pronunciations today.
What?
It was clog from Elena. Now it's
Logi.
logi.
Emoji. I would say loggy.
Okay.
Well, it's like clogging the type of dancing.
Yep.
So that's what it's saying we can do. We can clog.
Okay. Example 2.
Logi sounds like
We're going to expand again. What's my starting point for expanding this time?
yes, subtraction.
Okay. So there is a division. The log of two things being divided can be rewritten as,
The top of minus x.
yeah, the log of the numerator, so log of x squared minus 5 minus the natural log of x. Do you notice this one we were provided with ln, natural log, so what should you be using? ln, natural log. Okay, you don't get to change, you don't get to, it's not choose your own adventure. You have to go with what they want, okay? Now, we can go a little farther.
Something with the square.
Something with what?
The square.
Not exactly. Ooh, I miscopied this sign.
You could subtract the 5 into the front of the one.
We can only move powers to the front.
He's squared from parts.
No, it's not an equation, so I can't just randomly square things.
You could, it just wouldn't work.
I can't legally just randomly square things, so change the value.
So you can't clog.
Oh, but we can
Change the
clog.
base- We can clog.
We are going to use the power rule.
So can we do the square
Wait, is
root
it
of
the
x
2
squared?
ln?
Well, what do you know about a square root?
Oh my goodness, it's 1/2.
Okay, a square root power is 1/2. So before I use my power rule, I can rewrite the natural log of the square root of x squared plus 5 as the natural log of x squared plus 5 raised to the 1/2. Right? Radicals, square roots, cube roots, fourth roots, whatever, can be rewritten as powers. So now if I rewrite that as 1/2, the power of 1/2 can go where?
In front.
Out front. So this can become 1/2 natural log of x squared plus 5 minus natural log of x.
Yes.
And yes, the parentheses have to be around the x squared plus 5 because otherwise it could look like natural log of x squared and then a random plus 5.
And then plus 5, and then you can subtract from 5.
I always hate ln x because it makes me think I'm saying LAX wrong.
So officially we should be saying natural log of x. But I know when we're writing it, we often think ln x. Officially, I know, I'm just as guilty as you guys are. We should say natural log of x. So,
He was thinking the airport, like
Yeah,
LAX.
Oh, okay. Well, I had a student, Ellen, one year, and every time I said ln x, she thought I was talking to her.
So you didn't do the
But-
parentheses over the x, so I thought it was x minus 2.
Okay, now, and on this one, guys, x squared plus 5, you can't separate addition within a log, only multiplication or division. We move the power of 1/2 out front. This x squared power, we can't move that because, again, it's not on the whole log, it's just on one term within there. Okay?
I need to write that here. Do not separate.
It's so easy to get the rules confused backwards, so.
Have you been doing red and green for the Christmas spirit
Sure.
all week?
Yeah.
Really? I just saw that stuff.
Okay,
Wow.
example
I
3.
should have read my
Wait.
because yesterday was Pearl Harbor Day.
Example 3.
Anyways.
Instead of expanding, we're going to
Condense.
condense. So,
Condensation.
okay, thoughts here.
So we're obviously gonna have
ln x to the 5th.
Should we use the power rule first?
Yes.
Yeah, basically kind of reverse your steps from previous, right?
Yeah.
So definitely one thing I would do is I would use our power rule. So 5 natural log of x becomes
Natural log x to the 5th.
natural log of x to the 5th minus
Natural log xy squared.
natural log of xy quantity squared plus natural log
Y.
of y cubed.
Ah.
Okay. Now, a couple different ways we can proceed. What do you guys see?
Well, I would do division first because the subtraction.
Okay. So at some point we're going to have to do some division, right? There's 2 logs being subtracted, and they can be rewritten as 1 log where the insides are being divided. What else do we see?
Multiplication.
There's a log being added. When there's a log being added, it's going to be multiplied. Technically, we can do this in any form we want. Now, I know for me personally what makes better sense is to put my 2 logs that are added together first as a multiplication and then do the division, only because otherwise I'm going to get a fraction and then have to multiply in.
Yes.
Not that it's that difficult, but to me, personal opinion, it makes sense. I'm going to rewrite this before I do it. To put natural log of x to the 5th plus natural log of y cubed next to each other. So just so I can see them in my brain here, that those 2 logs are being added, and then subtracting the natural log of xy quantity squared. That's my idea. I'm not saying you have to do it this way. You can go a different route and still meet me in the end. Okay? Because now 2 logs being added can be rewritten as 1 log where the insides are 2 logs being added, rewritten as 1 log where the insides are multiplied. So this is natural log of x to the 5th, y to the 3rd, and it's still minus the natural log of xy quantity squared. And I'm running out of room, so I'm going to go next door. Okay, so I took the 2 logs being added, rewrote them as 1 log where the insides are multiplied. I still just carried down the natural log of xy quantity squared. Now that puts me in the position where I have 2 logs being subtracted, so I can rewrite that as 1 log where the insides are divided. So natural log of x to the 5th, y to the 3rd, divided by, what do you know about xy quantity squared?
It's x squared, y squared.
It's x squared, y squared. And for a reason you will see very shortly, I'm going to go ahead and write it as x squared, y squared.
Because you can subtract those.
Yeah. So now I have natural log, and it's 1 big fraction, x to the 5th, y to the 3rd over x to the 2nd, y to the 2nd. Clean it up. Guys, we're condensing. Our job is to clean this up as much as we can. So this is going to be natural log of x to the 5th divided by x to the 2nd is going to be x to the 3rd when you subtract exponents. Y to the 3rd divided by y to the 2nd is going to be y to the 1st. Yes, you should be in the habit of having parentheses around whatever's in your log if it's more than 1 of anything. Okay? Now, could you have done that in a different order and still gotten the same answer?
Yes.
Definitely. Okay? Not against that at all. Okay. Ready for example 2? Okay. Example 2 asks us to evaluate the following using the change of base rule. Okay, so log base 3 of 16. Do calculators have log base 3 buttons?
No.
No. Okay, so I need you to know how the change of base rule works. Change of base, how am I going to rewrite this, guys?
ln 16
Okay, so one option is natural log of 16 divided by natural log of 3. Can Delaney do this on her calculator now?
Yes.
Yeah, because she has an LN button. What's the other way I could write this?
Log 16 over log
Okay, and when you say log 16 over log 3,
log base.
you're indicating log base 10, which is my other log button. It doesn't matter which you do, guys. Give me an answer
2.52.
3 decimal places. What'd you say it was?
2.524.
Mm-hmm. .524?
Yes.
Did you get that all right?
Yep.
So you do the log of 16, just make sure you close the parentheses, divided by the log of 3, or natural log of 16 divided by natural log of 3. And to be honest, I don't know if you guys figured this out. It doesn't matter if you close an in parenthesis on your calculator. It just matters if you, when they're in the middle. So both ways come out to be that 2.524. What about log base 6 of 10?
Natural log of 10 divided by natural log of 6.
Okay. Natural log of 10 divided by natural log of 6, or
Log of 2 divided by log of 6.
log of 10 divided by log of 6. What do we get?
1.285.
Approximately 1.285.
You said approximately.
I did. I said approximately because we're rounding it, yes?
Yeah.
So, which is why I've been trying to put the squiggly equal sign, because it's approximately this. I'm rounding it. Now, I don't grade on that. I don't care if you use the squiggly equal sign or not, but, it's an option there. 3.
This one's natural log of 2 divided by natural log of 1.
Can we do that?
Yes.
Yeah. Officially, there's some other stuff you could do in there because it's the 2 and the 1/2, but I'm all for, let's keep it basic here. Natural log of 2 divided by natural log of 1/2, or log of 2 divided by log of 1/2. Either way, it works out to be
Negative 1.
-1. Notice I did not put the squiggly sign there.
Because it's not. That's
Exactly.
You didn't round it, did you? You gave me the exact answer. Okay? So, good skills to know. And in fact, we're going to use this skill here in a moment to do what it wants us to do on the graphing example. Okay? Okay, so notice it says describe. So we're going to be using words here. And it's asking us to describe how to transform the natural log of x into the following. So we're going back to our good old transformations. We did a lot with them in algebra. We've done some with them in pre-calc, right? And in order to do this, it asks us to use the change of base rule. And here's why we're using a change of base rule. It wants us to transform the natural log of x. However, is my function in terms of natural log of x?
No.
No. Can we rewrite this in terms of natural log of x?
Yes.
Yes, and that's what we're going to start off doing. So I'm going to take g of x, and instead of saying it's log base 5 of x, how can I make it natural log?
Natural log of x.
Natural log of x divided by natural log of 5. That's equivalent, isn't it?
Yes.
And the idea that it's equivalent is because I'm in terms of natural log, which is what they want me. Now, natural log of 5 is a number, yes?
Yes.
That's a number. I don't need you to get it, but you could enter natural log of 5 in your calculator and you can get a number, right? Some decimal. And so we want to know what is happening to natural log of x. So I'm going to take this natural log of 5, and I'm going to factor it out front, and it's in the denominator. So I'm going to rewrite this and say that it's the 1 over natural log of 5 times natural log of x. Okay? And the reason I'm doing that, again, because we want to transform. We want to know what's being done to natural log of x. So this would be saying, like, if it was natural log of x over 2. That's 1/2 natural log of x, right? Same thing, it's just a fancier number. Now, go ahead, it's going to help us along the way. What is 1 divided by natural log of 5?
No. Natural log of negative 5?
No? Give me a decimal.
0.621.
Okay. It's 0.621 times natural log of x. Okay, guys. What transformation is happening to the natural log of x?
Let's keep it multiplied by 0.621.
And what does multiplying by 0.621 do to a graph? Compress or shrink, right? Because when you're multiplying by a number, if it's a number bigger than 1, it will stretch it. If it's a number smaller than 1, it will shrink or compress, right? Just like if a number was being added or subtracted, it'd move it left or right or up or down. If it was multiplied by negative, it'd be reflected. Is any of this sounding familiar? Okay. So the idea here is that because it is this 0.621 times x, that means that this is a vertical shrink or compression by a factor of that 0.621 or 1 over natural log of x. So I'm going to write that out. This is a vertical shrink by a factor of, and you can either write it as the 0.621 or the 1 over natural log of 5. But when they asked us to transform it, or describe how to transform, that's what we're looking for. Okay. Well, and you can graph on your calculator to an extent. Here's what's going to happen, guys. First of all, do you remember what natural log of x looks like as a graph? I talked about it yesterday, right?
Yeah.
That it's basically, it goes like that, right? I graphed it yesterday when we were talking about that whole natural log of a negative being undefined. Now, so what does a graphed trunk look like? And it's very similar, other than basically it's going to pull down a little closer to the x-axis. And what you could do to see the comparison on your calculator is graph natural log of x and graph whatever this one was. So if I graph natural log of x as my first one, and then if I graph, I'm going to do it as 1 over, well, natural log of 5 times natural log of x. So there's my original. It's going to be hard to see, but notice the other one's coming in a little bit lower, yes? So that's the idea of what a shrink does. It doesn't change it much, does it? Which is why I wanted you to see kind of what the original looks like. Okay? I know, I'm debating if it's worthy of looking at the next one or not. I'm not sure it is.
Is this where
I wrote it out.
What?
The same.
Is this where the first class left off?
Yes, this is what I did with the first class. This is what I did with my morning class. So I think you'll be okay if you have one of those. Honestly, I'm trying to remember. Do I even still? I think I still have those in the homework. But I think we'll stop here because otherwise I'm afraid we get interrupted by the bell.
We typically did it.
What's
Can
new,
you give
right?
us the answer? Because I think I might almost have it.
Oh, maybe I. Shoot. Wait, what do I have your homework? I only have your homework going to 28, don't I?
Yeah.
Okay, I dropped these off the homework anyways. That's what I thought.
Like,
So, no. Okay, now, what is your homework that you need to get done with this group?
1 through 28 on page 283.
Okay, page 283, 1 through 28 goes with this lesson. Okay? Okay, you've got work to do tomorrow, right?
Yes.
And maybe some tonight.
You know how I liked
I think
when our
I'm
stuff
good.
was Mr.